our goal for today's lesson, this is like the big idea. Why we've been doing matrices these past couple days, all leads up to today. Today's lesson is how do you solve a linear system with matrices? It's exciting. You get to find that point of intersection using matrices. We get our last little Matrix movie quote there too. But right now you're probably focused on your definition for a multiplicative inverse. So we'll go ahead and talk about this definition, but honest to goodness, you already know how to use multiplicative inverses super well, so I'll show you, I'll connect this to something that you know here in a second. But by definition, a multiplicative inverse for us is going to be a pair of numbers, or in this section, matrices, whose product, in other words, when I multiply them together, I get the multiplicative identity. So it's a pair of numbers or matrices whose product is the multiplicative identity. Now, if we're looking at just plain old numbers, your multiplicative identity is 1. Because you can multiply 1 by anything and get that same number back out. So right now I'm going to take a hot second to clear up how multiplicative inverses and identities are tied together. Okay, back in the day, you may have to solve equations like 3/4 x equals 2. There was a fractional coefficient in front of that x, right? How did you get rid of that fractional coefficient? Go ahead, Ashley. Not by the opposite reciprocal. That was if we were talking about perpendicular. Just the straight reciprocal would get rid of that 3/4, right? So you would multiply both sides by 4/3. What we do to one side, we do to the other. Now, why did that help us out at all? Why did we multiply both sides by 4/3? What did that do for us? How? You have some help. Go ahead, Chris. Yeah, what we end up with there is 12 over 12 in front of our x. So do you see what we're saying here? It's that relationship that we're talking about in the vocab terms. When we find a product, and that product gives us the identity, like 4/3 and 3/4, those things are inverses of each other. Does everybody see that? So we have this idea that we could get rid of a coefficient by just multiplying by an inverse. Well, today we don't just have fractions as our coefficients. We're going to talk about having coefficients that are matrices. Actually, a coefficient matrix is what we're going to produce today. So the identity looks a little different when we talk about matrices. It's going to be another matrix. It's going to have 1s across the diagonal and 0s everywhere else. So our most common identity matrix is going to be a 2x2 identity matrix, where we have 1s across the diagonals and 0s everywhere else. We get the identity matrix if we multiply a matrix by its inverse. So in today's lesson, if we want to get rid of, whoops, sorry, wrote something wrong. Don't write that yet. Eraser. If we want to get rid of, let's say, a coefficient matrix A, what we're going to study in today's lesson is that we could just multiply it by its inverse, and we would get the identity matrix. And did you see what I wrote there? This a to the negative first. Remember how yesterday I said the matrix button and the little x to the negative first are tied together in a certain way? This a to the negative first is what we call the inverse of matrix A. So whenever you see the entire year, because this comes up several times, whenever you see an exponent of -1, we're going to talk about that actually being an inverse. Yes?
Is that the same thing as 1 over A?
Yeah. When we're talking about, if we're talking about like this right here, like a number. But with matrices, we don't do it exactly that way. Matrix division is a little different. It doesn't follow the same rules as regular numbers. Just like the commutative property from yesterday, regular multiplication, yeah, 3 times 2 is the same as 2 times 3. But we saw in yesterday's lesson that A times B isn't the same as B times A. So these guys follow a different set of rules. And it has to do with the fact that, you know, when we multiply, there's also addition involved, which could be subtraction, which is never going to be commutative. So that's that. But yeah, the upstairs-downstairs rule, or where you shove that to the bottom, that's important. And we'll talk about that a little bit more in the year too. But for the most part, yeah, we're talking about that being an inverse. Which is a nice segue into example 1. It says use a calculator to find the inverse of this 2 by 2 matrix. So what I'm going to go ahead and have you find, and we're going to work it out together, we need to figure out what A inverse is going to be. So we're going to grab our calculators. I hear you opening them. And we're going to use the same buttons we did yesterday. You're going to press second and x to the negative first. And you are going to scroll over to edit and select matrix A. Matrix A is still 2 by 2 today. And you're going to enter the elements 3, 8, 2, and 5. 3, 8, 2, and 5. Then, in your calculator, you're going to hit second, quit, go back to your home screen. We're going to call up matrix A by name. And to do that, we press second and x to the negative first. And I see that my number 1 is darkened and my names is darkened there. I'm just going to go ahead and press enter, and A pops into the top right-hand corner of my screen. Then I just hit that same matrix button again, that little x to the negative first, and a little exponent of negative 1 gets there. And then you press enter. Everybody on their screen should see right now the matrix negative 5, 8, 2, and negative 3. Anybody not get that? Not know what they typed in wrong? Okay, so you go back to your home screen. So second, quit. Hit second matrix again and press enter. So A should pop into the corner of your home screen. And then to get the little negative 1, just hit that matrix button again. And then do you see the little negative 1 pops in? And if you press enter, you get that. Did you get that, Chris? Okay. Anybody else? Okay, wait, this is super fun too. Okay, so what I want to do is tell you I'm not full of baloney. This business actually happens. So what we're going to go ahead and do right now in our calculator, I want to play around with the idea that, yeah, is A inverse times A, if I multiply those things together, do I get the identity matrix? So we're going to type that into our home screen right now. So I'm going to press second equal sign, that brings down my answer, and I'm going to multiply that by second matrix A. So I'm taking A inverse times A right now in my calculator. And you should get a matrix that goes 1, 0, 0, 1. They might not get that. So that is the matrix I could multiply by any other matrix I want, and I would get that same thing back out. You do get that identity matrix. So if you type this in your calculator, you do get 1, 0, 0, 1. This is important because it's technically what gets rid of a matrix. If you have a coefficient matrix, this is what undoes it. They might not get the identity matrix on their screen. Okay, so now let's use this information. So here in example 2, we're going to use this information to solve for x. We're going to undo a matrix. We're going to undo matrix multiplication. So the problem reads, solve the matrix equation ax equals b for the 2 by 2 matrix x when a equals 2, negative 7, negative 1, 4, and b equals negative 21, 3, and 12, negative 2. So what they want me to do, see this x equals b, I'm going to copy that down. and they want me to solve this equation for x. But this time around, the coefficient and what's on the other side of the equal sign are matrices. So again, if I want to get this matrix A to go away, if I want to get rid of this so that I can isolate x, I have to multiply both sides by my inverse. So what I'm going to do is I'm going to multiply this left side of the equal sign by A inverse. When I do that, I get the identity matrix, which just is what allows me to get that x all by itself. So these two things are going to undo each other. However, you folks know it. What I do to one side of an equal sign, I have to do to the other. So that means I need to multiply the right side of the equal sign now by A inverse. Notice I had to put it to the left of B because matrix multiplication is not commutative. So I can't do B times A inverse. It will not be the same as A inverse B. So if I multiplied the left side by A inverse, I also had to multiply the left side of B by A inverse. Okay, this, my people, if you take away nothing else today, what I just told you up to this point is just backstory, just a little information. Won't be on your test. But A inverse B is something you have to know how to type into your calculator in order to solve a linear system. So what we're going to do right now is practice getting that A inverse B. So matrix A, we're going to go ahead and key that in. So we're going to press second matrix, scroll over to edit. We're going to edit matrix A. It's still 2 by 2. And I'm going to enter in 2, -7, 1, up, -1. Careful, it's a -1 there. And 4. And I also need to now edit matrix B. So second matrix over to edit, down to B. That's 2 by 2. And I get -21, 3, 12, and -2. And then in my calculator, I want to go ahead and type in my home screen A inverse B. So I press second matrix, call up matrix A, hit my little x to the -1 button, and then I'm going to call up matrix B.
Should we put the multiplication?
You don't have to. If you leave it out, it's implied. Remember when you have two letters put together, the multiplication is implied. So you could put times if you want to, but you don't have to. Good question. And then when I did this, I got 0, -2, 3, and -1. So this is the matrix that I could multiply by A, and it would give me B back out. So the magical formula, you know how like you used to learn the Pythagorean theorem, or you would learn the area formula for a regular polygon, or you might learn the formula for the area of a trapezoid. Today's sort of formula to solve for a matrix is A inverse B. That's our formula for today. Okay, now, the beauty of this, finally, we get to the moral of the story, is that we could use this A inverse B to actually solve a linear system. That eyes on the prize is what we're trying to get done today. Okay, ready to do it? You're going to love this. This is awesome. It's super fast, too. So do you see I have an equation 2x plus 3y equals 19? And then I have another equation that's technically 1x plus 4y equals -7. Can anybody tell me what form those equations are in? Standard, okay? You should check to make sure your equations are in standard form first. On your quiz next week, I will let you know not all of your problems are in standard form. So if you're going to use this technique, you're going to see why in a second, you have to make sure your equations are written in standard form. Okay. What this then allows me to do is write 3 different matrices, and we're going to build something right now. It's called a matrix equation. So we're going to take this linear system right here, and we're going to rewrite it as a matrix equation. The first part of your matrix equation, whoops, I can't spell. The first part of your matrix equation is what we call your coefficient matrix. Coefficient matrix. And it's comprised of none other than your coefficients on the left-hand side. So to build your coefficient matrix, you're just going to grab your coefficients, which were 2, 3, 1, and 4. We then multiply that by our variable matrix. The variable matrix is just x and y. And then we set this equal to, on the right-hand side there, is what we call our constant matrix. Our constants go 19 and negative 7. And every once in a while I get asked the question, why'd you set it up like that, Mrs. Lucas? Okay, a couple reasons. One, think back to yesterday's lesson. I'm multiplying a 2 by 2 times a 2 by 1. Those inside numbers need to match, so it has to be set up like that. The answer matrix is then 2 rows and 1 column. So this checks out. That's a 2 by 1 for my solution, for the product. Okay, furthermore, remember how we go about doing matrix multiplication. What I've generated here is an equation that's logically equivalent to this line up here. Check it out. Ready, watch. If I do the multiplication on this side, based on yesterday's lesson, I have 2 times x plus 3 times y should give me 19. And that is verbatim what's written up there. It works for the second line too. We can take 1 times x plus 4 times y, and I should get negative 7. So all I've done is I've generated the matrix form of that linear system, just based on yesterday. Does that make sense? Not that you necessarily even need to know that, but I just wanted to show you that this isn't, like, I'm not making up rules here. This is, those two lines say the exact same thing. Okay, now, this is awesome. Okay, I need to do what I just did in the previous example. I want to get this by itself. I want to solve for x and y, right? So in my calculator, I'm going to go ahead and call this guy matrix A. I'm going to go ahead and call this guy matrix B. And then to get x, y all by itself, I know that I can multiply both sides by A inverse. And if I want to get x, y by itself, I just need to type in A inverse B. So let's go ahead and take a second to do that. First things first, I got to edit matrix A. So I'm going to type that in as matrix A. So I have second matrix, over to edit. Matrix A is still 2 by 2, so this is going to go 2, 3, 1, 1, enter, and then 4, enter. And then matrix B, I have to edit that. Keep in mind, you got to change the size of that matrix. It's 2 by 1, 2 rows and 1 column. So I got 19 and then negative 7. And then again, the formula we're doing today is this A inverse B. So I'm going to call A inverse B up into my home screen. So second matrix A inverse second matrix B. Oh my gosh, I forgot to tell you a shortcut too. And what I get, you see I have decimals in my answer there? I get my matrix to be 19.4 and negative 6.6. And that is what x and y is, right? So what I understand now is that the value of x should be 19.4 and the value of y should be negative 6.6. So you could even write it as an ordered pair now, which would be so messy to graph, right? Much easier. Doesn't matter how messy your numbers are, you can just throw them into a matrix. So nice. Okay, are there questions about that? So let's review the steps real quick. First, you want to make sure that your system, the equations are written in standard form. so that your X's are under your X's, your Y's are under your Y's, and your numbers are under your numbers. If that's not the case, you can't actually leap into writing this because you're writing an untrue statement. So you have to make sure that everything's all lined up first. After you write your matrix equation, you're going to edit matrix A and matrix B and do A inverse B to get your answer. Want to do it again? We'll do it within the context of a word problem. Let's see how it goes. Okay, so we'll read this together. It says a company sells 3 types of movie gift baskets. This is common, like you go to a silent auction and there's all those baskets there. You know, you can put raffle tickets in. A company sells 3 types of movie gift baskets. A basic basket with 2 movie passes and 1 package of microwave popcorn costs $15.50. A medium basket with 2 movie passes, 2 packages of popcorn, and a DVD costs $37. And then a super basket with 4 movie passes, 3 packages of popcorn, and 2 DVDs costs $72.50. Find the cost of each item in the gift basket. So you might be right now going through, I see some of you writing, you're circling things that you know, you're identifying things that you don't, and then those things that we don't know, we assign variables to. Right now this problem's telling me I don't know the cost of each of these things. And I saw 3 different items in my basket. Did you? I saw popcorn, I saw movie passes, and I saw DVDs. So I don't know the cost of those items. So I'll call X the cost of my movie passes. That was the first item I saw. I'm going to call Y the cost of my popcorn. And I'm going to call Z the cost of the DVDs. Do you see what we're going to solve for, friends? 3 variables. We only do that with matrices. We used to do it by hand, like with algebra. It's long. So now we just teach this with matrices. So if you ever have to solve for 3 unknowns, you're going to the matrices. Not to be confused with going to the matrices, different altogether. Okay. You ready? Let's write some equations. I think I'm going to write 3 equations because I have 3 unknowns. And I see 3 different baskets. There was like your basic one, then your medium one, and then there was like the super basket. Okay, I'm going to write the first one. Let's see if we can monkey see, monkey do our way through this. I'm going to write the first one. You folks are going to help me write the second and third. All right, I'm going to do the basic basket. The basic basket has 2 movie passes. So that's 2 X's. And 1 package of microwave popcorn. Oh yeah, and no DVDs. They have to be in standard form. You have to have an X, a Y, and a Z, right? You can't just leave that out. 0 is going to be a number you have to type into a matrix. Like you can't leave an element in a matrix blank. Your calculator will give you an error. When I multiply and add, I get the cost of our basic basket. It's $15.50. Can anybody help me with the medium basket? Go ahead, Ashley.
2x
Yep.
plus 2y
Yep.
plus 1z
Yep. Legit. Somebody else besides Ashley. Feeling brave. Good, Karsten. Nice. Good. Yep. Oops. Yep. Just had some hand-brain disconnect there. There it is. 3 equations, 3 unknowns. So we're not going to necessarily, when we go to write our matrix equation, we're going to have a 3 by 3 matrix over here. So this is going to be 3 by 3 because I see I have 9 elements to fill in. And then this will be times x, y, z. And then that's equal to your constant matrix, which is 3 by 1. So we'll do 15.5, 37, and 72.5. I would call this matrix A, call this matrix B. And we're going to go ahead and solve for x, y, z. And I'm going to let you do that.